Welcome to this third video of lesson Pythagoras Theorem from Mathematics Part 2 of Standard 10. In previous video, we have learned similarity and right angle. We have proved the theorem and one more theorem we have proved geometric mean. Now here we have seen that in the previous video also that we are going to use the similarity in right angle triangles for the proof of the statement of famous theorem Pythagoras theorem. This theorem or this proof is very much important for you as a part of the examination. Okay. After that we will see the converse of the Pythagoras theorem also. So as we know the statement of Pythagoras theorem that in a RAT, that is right angle triangle, the square of the hypotenuse is equal to the sum of the squares of remaining two sides. For this, of course, we have to draw one right angle triangle. Okay, so suppose this is a right angle triangle ABC, where that angle P is 90 degree. Okay, so let's write this as given. So given in triangle ABC, angle B is equal to 90 degree, and then we have to prove that. So it's only right angle triangle, and then we have to prove the square of the hypotenuse. Here the hypotenuse is AC, so AC square is equal to AB square. Remaining two sides are AB and BC, so we have to take sum of their squares. So this is the sum of squares of remaining two sides. This we have to prove. Of course, this statement we have used this many times, so we know this perfectly, this statement. So here much explanation is not required. Okay, now to prove this, what we are going to do, as we have mentioned before, that we are going to use similarity in right angle triangle. And for that, what do we require? What is that statement? That in right angle triangle, the altitude drawn on the hypotenuse, okay, divides that triangle into two parts, and this each triangle is similar to the original triangle and to each other. So this is the statement of similarity right angle. How this is going to be useful to us? Now we know that these two triangles are similar to ABC. Okay, so this triangle ABC, this is similar to what? Suppose we want to take this AB, this is D. So this is D point. Okay. So actually this is not in the given. We are doing something extra which we will write as a construction part. Say we have perpendicular on the perpendicular. Now in triangle ABD, we have to prove these two triangles. We have proved these two triangles with this by A test, where A is the common and B and D are right angle. So at for first angle triangle ABD, A first position is second position, third position. So first position we will write A, second is 90, here D is 90 and remaining is B. So ADB is similar to ABC, and let's take this one also similar, BDC. Now here the C angle is going to be common. So here if you okay, let's write this much only. This is too similar, and triangle, this both are similar. Okay, so C first, second, third position. First, second, third. C is common here. C is common. D is 90. Here B is 90. So here D will come and the remaining is B. So ADB is similar to ABC and BDC is also similar to. So we can take this similarity in right angle triangle. Now using this, we can take the corresponding sides. Now which corresponding sides we will use? Now here the target should be, we want AB square and we want BC square. Okay, because we have to do addition. So just from this similarity, what we can get? Where is AB? AB is first and third. So here what is first and third? It is AC. So from this we can say that AB upon AC is equal to, where is one more AB? AB is here in this as first and second. So here the first and second is AD upon AB. So we can get from these two similar triangles, this is the corresponding sides, and you can see by cross multiplication we can get it AB square. AB square is equal to what? AC into AD. So this can be our first statement, and we have got the value of AB square. Now from the second, this triangle, this pair of similar triangles, let's try to get BC square. Okay, so where is BC? BC is first and third. So if you take the first and third letter BC, the corresponding first and third is AC. So BC upon AC. Here BC is second and third. So second and third. Here it is DC upon BC. These are your corresponding sides. To take the B cross multiplication, so you will get it BC square is equal to what? AC into DC. So statement number 2. Now on the right side, as you want to do the addition, and then that addition should be shown equal to AC square. So if you add these two statements, what you will get? You will get sum of this AB square plus BC square is equal to here AC into AD plus AC into DC. Here you can find AC is the common. So if you write AC is common, then in bracket you can get it AD plus DC. And what is AD plus DC? AD plus DC. You will get it AC. So there's D somewhere in between A and C. AD plus DC. By addition we get it AC. This is nothing but AC. So this is what AC, and this is again addition is AC. So here you can get this as AC square. And hence we can prove this AC square is equal to AB square plus BC square. So this is going to be plan in which we are going to follow. Now for this we require this construction. So let's write that construction part here. So construction. See, once the plan is chalked out, writing the proof is just mechanical part. Okay. Draw BD perpendicular to AC. As we want to do addition, let's write that betweenness also, comma A dash D dash C. Okay. So we have written that betweenness, so we can add it here. Okay. So if everything is planned, then accordingly we can write that answer. So proof part. Okay. Now using similarity in right angle triangles, we can write this, and triangle ADB is similar to triangle, we can write it together also, BDC similar to triangle ABC. We can say statement number 1 here, and the reason is similarity and right angle triangle. Similarity and right angle triangle. This is the reason. That's why these three triangles are similar to each other. Okay. Now taking this first and third. So triangle ADB is similar to triangle ABC. Okay. So we have taken the help of that theorem. From 1 we can write, and now here we are going to take AB square. Here we are, as AB is the common angle over here in these two triangles, we are taking AB. We have already done, so we can just copy it. So AB upon AC is equal to AD upon AB. Here we need to write only the reason, corresponding sides of similar triangle, and therefore AB square is equal to AC into AD. This is statement number 2, which we will add it with another statement 3. Okay. Now let's rub this part. Let's continue here. Okay. So now here another triangle we are going to take. Triangle BDC is similar to triangle ABC from 1. Okay. And that's why now here we want BC. So BC upon AC. See how I am writing, you can see that first and third letter corresponding. And here BC is second and third, so here second and third is BC upon BC. So these are the corresponding sides of similar triangle, CSST. From this we get BC square is equal to AC into BC. This statement, which can be say as statement number 3. Now adding 2 and 3. Okay, we are going to write the last part now here. Let me clear it so you can see the blackboard clearly. So adding 2 and 3, what we get? We get AB square plus BC square is equal to, this is AB square, here is BC square. We have added LHS to LHS. RHS is what? AC into AB plus AC into DC. Now here as we have seen that AC is the common, so AD plus DC, and at AD plus DC will give you AC. You can write the betweenness A dash D dash C, which we have written here as construction, correct? So now this is going to be equal to AC into AC is AC square. Therefore, AC square is equal to AB square plus BC square. This we have proved, which we want to prove, okay? And hence the given statement is proved. So this is the way in which we have to prove the Pythagoras theorem. In question, you will get the statement and then you will write all this given to prove construction and proof part. I hope you have understood. Now let's see the converse. Converse is generally not asked to prove, but its application is there. But still, let's learn how to prove this, because there is no such guarantee that it cannot be asked for the exam. And for knowing seeking the knowledge, we should be knowing it. Forget about the exam. Okay. So what is this statement? Let me rub this part now for you. Actually, we can rub this part also. We do not want it now. Now the statement is with us. So let's read the statement of the converse of Pythagoras theorem. In a triangle, not right angle, simple triangle, if the square of one side is equal to the sum of the squares of other two remaining sides, then the triangle is a right angle triangle. Okay. Now here we have to prove that it is a right angle triangle. So we have to draw a right angle triangle. So if I draw a right angle triangle such that, so this A, B, C, but I will not say that B is right angle. I have drawn that B is right angle only, but I will not say, I have to prove it is. Okay. So in a triangle, so what will be our given? Okay. So given can be in triangle ABC, where we are not going to write B is 90. We have to prove that square of one side. Okay, which side we have to take? Of course, we have to take the longest side. If this is B is right, AC should be the longest. If triangle ABC, AC square is equal to sum of squares of remaining two sides. Remaining two sides are AB and BC. So it's AB square plus BC squares. Now this is given. Okay. In the original theorem, we have proved this. Now this has become given. Then the triangle is a right angle triangle. So this we have to prove that the right angle is a right angle triangle. So we have to prove that. Okay, to prove triangle ABC is a right angle triangle, or you can say angle B is 90 degree, or you can say triangle ABC is a right angle triangle. Anyway, we can write is a right angle triangle. Let me make it short. Okay, so this has become a proof. Either you can write to prove this or this. Any one you can write. Okay, now how can we prove without any help? We know just AC square is equal to AB square plus BC square. Now here, let's do one construction. Let's draw one right angle triangle and let's say it is a right angle triangle, and then let's see what we can do. Suppose I am drawing a right angle triangle PQR. Okay, suppose this is PQR such that angle Q is 90 degree. Now AB, whatever AB is equal to PQ, whatever BC and QR it is equal. So what we have done construction, we have drawn another triangle PQR where AB and PQ is same, BC and QR is same. Only we will say that Q is right angle. And if we can prove this two triangles congruent, then we can prove this is 90, this is also 90. Okay. Now here we have drawn a properly right angle triangle. So what we can do? We can use Pythagoras theorem in our new constructed triangle, and we can say that in triangle PQR, it is Q is 90, correct? Angle Q is 90 degree. That's why PR square is hypotenuse is equal to PQ square plus QR square. Okay, this is as per Pythagoras theorem. But now PQ and AB is equal. So we can, if PQ and AB is equal, its square is also going to be equal. So PQ square can be replaced as AB square. And QR and BC are equal, and QR square can be replaced as BC square. Okay. But in given it is said that AB square plus BC square is what equal to AC square. This is our given, AC square. So here what we find that PR square and AC square they are equal. So taking the square root of both sides, we can get it PR is equal to AC. So we can prove that these two remaining sides are equal. And if these two sides are equal, so if these two sides are already equal, we can prove the third is also equal. So we can prove these two triangles are congruent by S test. Three sides, corresponding sides. And these two triangles are congruent. Okay. So we can prove that triangle ABC is congruent to triangle PQR by SSS. And if these two triangles are congruent, then angle B is going to be congruent to Q. Now Q is 90, that's why B is also 90. So this way we have to follow. So let's write the construction part here. I hope you have understood what the method we are going to use. Construction. While writing this construction, you need to be careful. Draw triangle PQR such that AB is equal to PQ, BC is equal or congruent QR, and third is angle Q is equal to 90. Okay, so we are stating that angle Q is 90, that's why it is a right angle. Okay, now let's go to the proof part. Okay, now in triangle PQR, angle Q is 90 degree. Why? It is construction. We have only done the construction, and that's why now we can apply the Pythagoras Theorem here, and therefore we can say PR square is equal to PQ square plus QR square. The reason is Pythagoras Theorem. Okay, therefore PR square is equal to PQ is replaced by AB and it is square, that's why AB square, and QR is replaced by BC, that is BC square. You can say this PQ is equal to AB and QR is equal to BC. You can say like that, or you can say construction, and therefore PR square is equal to, what is this AB square plus BC square? It is AC square. So here you can write given. And if PR square and AC square equal, then this PR is equal to AC, taking the square root. Okay. So now when we have proved these three sides are congruent, therefore we can prove that these two triangles are congruent by SSS test. Let me continue. Therefore, triangle ABC is congruent to triangle PQR, okay, by SSS test, and therefore angle B is congruent to angle Q, corresponding angle of congruent triangle, and as angle Q is 90 degree, angle B is also 90 degree, and therefore triangle ABC is a right angle triangle. Okay, hence the given statement is proved. So in a triangle, if square of any one side, that one side is going to be surely the largest side, is equal to the sum of the squares of remaining two sides, then the triangle is a right angle triangle. So this was the converse of Pythagoras Theorem. In this way we can prove. We will see in the next video the application of whatever theorems we have learned so far in solving sums and doing some proofs. Thank you. I hope you all like this video. Please give me the like and comments. And yes, if you are not yet subscribed to the channel, please subscribe. Thank you very much.